Hello, and then today we're gonna learn about fractions and percentages. Yup. So fractions and percentages is covered in topics in Year 7. Even they also do in Year 6. Today we're gonna do it from the Year 7 2024 Cambridge book. We're gonna do the questions from there. Don't worry, this video won't be too long. It's just an introduction. I will split it into parts by part. Okay? So when we go to learn about a topic, and let's say they give you a chapter, we first gotta go see the skill sheet. So now in the skill sheet, what they're asking, so if you go to the bottom page, it's always in the third last page or fourth last page, the skill sheet. So if I just go to the end, we have the chapter. We have the checklist, not skill sheet, sorry, checklist. So we have the checklist here. So zoom in. And yeah. So if I just go do it in red marker, it's a bit better. Yeah, red. Yes. No, this is good. Red marker is good. So if I go do all this in red marker, it'll be good. So now for checklist 1, this is like a pre-test, and I'm going to teach you the checklist. Then we'll go through the questions. I can identify the numerator and denominator of a fraction. Can you identify it? So the example question is a pizza. Just go zoom in. A pizza has been cut into 8 pieces, with 3 of them selected. Write the selection as a fraction and state the numerator and denominator. Yeah? We have been how do we represent the fraction? So we know that there have been total 8 pieces. So we put 8. So this is too big. I gotta put 8. Yeah? We put a line. I think it's called the Winsula. And we put 8. And then they have said, with 3 of them selected. With 3 of them selected, there's 3. So we put 3 over 8. So that's what we do. If you don't know, I will teach you right now. So basically, if they give that, you have to first find the total, all pieces / sections. I have to find that, the total of all pieces / sections. So there's been 8. The total is 8. So we then put this line. We put 8 on the bottom. So denominator must be that. What about the numerator? What is selected / chosen? Selected or chosen? There's been 3 here, as it says, so we put 3 over it. So the answer for this is 3 over 8. Let's go that. Yeah? The answer for that is 3 over 8. So let's put here equals 3 over 8. And then if you succeeded in it, we put a tick. Okay. I can represent fractions on a number line. So how do we represent them in a number line? So let's say we have this. And then let's put a straight number line over here. Not very accurate. I think you can manage it. Okay. Then So we represent, let's represent this as 1 over 5, 2 over 5, 3 over 5, 4 over 5, 5 over 5. Yeah. And then we represent, this is 6 over 5. Not very accurate one, but you can get the point of what I'm trying to do. 8 over 5. Let's expand this. And then you have 8 over 5. And then we have here 9 over 5. Yeah? So we plotted this all in a number line. So what do we do now? What we do now is this. Okay? So they say 3 over 5. Plot 3 over 5 and 9 over 5. Where's 3 over 5 in this number line? Here. What about 9 over 5? Here. So we plotted them both in the number line. Just put an arrow. We don't, no, not arrow. Put a dot. That. So that's what we do. And that's the answer. I'll be going, it's just an introduction, just saying. All of them are just an introduction. So you do not have to worry about it. Because I'm going to teach you more in the next part, which I'm going to be uploading. Mind, what am I doing? Like that. Just put here. Space. And if you did it correctly, we can put that. Okay, now let's do the next question. The next question was represent the fraction 3 over 4 in 3 different ways. Using a square divided into 4 equal regions. Okay, so we put a square here. We need to represent it in 3 different ways. What about this way? Just make it more squares. You can do that. And then we just go shader. We can just go put, and then we can put that. Put that. So we're filling out 3 out of this 4 total. We're filling out 3 of them. What about let's do this one. What about we can make them into these isosceles triangles? You can do that. We can do that. Yeah? And when we do that, we have that. Fill out 3 of the parts. And it goes to that. What about doing another way? 3 different ways, as they said. Okay, that's my square. And how do we make it into 3 different ways? We can do, let's go. We did the squares one. Let me think of a different way we can do it. Can we do it? Oh yeah, we can do it this way. Do that. Okay. Okay. Just do it straight or not really straight. Okay, I'm wasting so much time. Okay. Yes. Do that. And you get what I'm trying to do. There's 4 equal regions, and we have to represent the 4. We have 1. We fill out 1 of them. Fill out the second one. And we can fill out the third one. Fill it anyway. You don't have to fill it continuously. Anywhere in this diagram. So that's 3 4. So that is correct. And if you did it correctly and you know it, you put a tick. Checklist. So that's what we do. for this question. Nothing. Okay, I'll put this and then okay. Now let's go to the next question. I can produce equivalent fractions with a given numerator or denominator. So they're saying 2/3 equals to question mark over 12. How do we do this? So we know they're saying this is equivalent. This is equivalent. So if we want to make it 12, how do we make 3 to 12? We have to multiply by 4. So you ought to multiply 4 on both sides. Because if they're equal, then you have to multiply the same number on both sides. So what's 2 times 4? So what's 2 times 4? Well, 2 times by 4 is all equal to 12. 2 times 4 equals to 8. So we put 8 over 12. Yeah? We put it as 8 over 12. Now, that's what we do here. We shouldn't simplify it. So we just put it it's not asking us to simplify it. And if we simplify the question, there will be no point of the question. Now, we're gonna try. They're saying 4 over 5 equals to 12 over question mark. 12 over question mark. So they're asking us to find what this is a question mark equal to. As I mentioned before, what do you multiply 4 by to make it 12? You multiply it by 3. So you multiply it by 3 on both sides. And that equals to 12 over 5 times 3. It's 12 over 15. So we put here 15. Not simplifying it, that this question would be pointless then. So that's what we do. Yeah? That's what we do. So let's go to the next question. If you did it correctly, put a tick. Go to the next question. I can write fractions in simplest form. So can you write the fraction 12 over 20 in the simplest form? How do you do in the simplest form? You have to divide both numbers. So divide both numbers by the HCF. Divide both numbers by the HCF. That's the formula to find the simplest fraction. Yeah? So the keynote, so I'll just put it here. So we divide both numbers by the HCF. That's what we're going to do. So what's the HCF of 12 and 20? What's the HCF of 12 and 20? HCF of 12 and 20, it equals to 4. The HCF of both of the numbers equals to 4. So we found the HCF of them. Now let's divide them by 4. So if we divide 12 by 4, it equals to 3. 20 divided by 4, that equals to 5. So 3 over 5 is the simplest form. Tick. Okay. I can decide if two fractions are equivalent. How do we do this? So the saying is 4 over 5 equal to 20 and 25. Yeah. So is it equal to or not of 20 and 25? You have to find if we divide this by that and divide this by that, they must equal to the same numbers in the numerator and denominator. So what's 20 divided by 25? What's 20 divided by 4 first? So 20 divided by 4 equal to 5. So we put 5 over something. And this must equal to 5. If it doesn't equal to 5, then it's not equivalent. So what's 25 divided by 5? That also equals to 5. So it's 5 over 5, which means it's equivalent. So it is equivalent. It is equivalent. It's equivalent. Yeah? That's what we do. Okay? It is equivalent. Tick. We'll go to the next question. I can convert mixed numerals to improper fractions. Mixed numerals like this, how do we convert it to an improper fraction? Before that, we need to know what improper fractions even are. Improper fractions are fractions like this, or even this. Yeah, these are examples of improper fractions. So I want to convert it into an improper fraction. How do we do that? In a mixed fraction, we need to let this area remain the same. That area should remain the same. So if I want to convert it into an improper fraction, that area needs to remain the same. What about for the numerator? So as we see here in the next numeral, the numerator, how do we do it? We have to multiply this denominator by this number, just 3, and then add 1. So times we have to multiply it by, and we have to add it by. So what's 5 times 3? 5 times 3 is 15, and plus 1 is 16. So I have to do 5 times 3 plus 1, which equals 16 over 5. And that's the answer. So we put 16 over 5. 16 over 5. So we gotta put that. What's the next question? You can convert from an improper fraction to a mixed numeral, simplifying if required. So they're saying 11 over 4, right? 11 over 4. We can't simplify it further. So how do we convert it into a mixed numeral? How do we convert it? So how many times can we multiply 4 by to make it 11? How many times can we make times 4 by to make 11? 2 times. So 2 times, and that equals to 8. So what's 11 minus 8? 11 minus 8 equals to 3. So we put 3, and then you should remember that this new denominator must always equal to the same. So it's 2, 3 over 4. That's to convert into numerals. What about 20 over 6? We can simplify this number if you divide by 2 on both sides. So that's 10 over 3. So instead of 20 over 6, that's not good as 10 over 3. 10 over 10 over 3. Now how many times can 3 go to make a 10? 3 times. And what's 9? What's 3 times 3? 9. And what's 10 minus 9? That's 1. So put 3 and denominator must equal to the same. So this is the answer for both of them. So just tick it. Let's go to the next question. I can compare two fractions to decide which is bigger. So you can compare them to decide which one is bigger. Which is bigger, 2 over 3 or 3 over 5? So we have to make them all equal to the same denominator. So we'll make 2 over 3 and 3 over 5 to the same denominator. What's the HCF of 3 and 5? It's 15, right? No, HCF, sorry. LCM, 15. So to make 3 15, what do we have to multiply by? 5. So you have to multiply this by 5, and the top number also multiplies by 5. 10 over 15, 2 over 3 equals to 10 over 15. And then we have 3 over 5 is 3 over 5 is, how do we make a 15? Times by 3, so it's 9 over 15. 2 over 5 is 9 over 15, 2 over 3 is 10 over 15. So which one's bigger, 10 over 15 or 9 over 15? We know 10 is bigger than 9, so we put 10 over 15 is, what's the bigger symbol? Which one's the bigger symbol? This or that? It is this. How do we do it? As you can see, when we write it down, we see this and we see that. This number, this thing, it looks like an L, right? Looks like tilted L. Looks like tilted L. So this looks like tilted L. When I see this, I'll think, okay, it looks like an L. I'll put lesser. And this one, if this is lesser, this must be greater. So this is greater. So we put this. 10 over 15 is that to 9 over 15. If you simplify both of them, simplify the fractions, it gives that 2 over 3 is bigger than 3 over 5. So that's what we're doing. Yeah? That's how we find it out. So it's so we did it correctly. Let's put that. I can order fractions in ascending or descending order. How do you do that? We have to make them all the same denominator, so I'll just do that. Okay, we can do it. Okay, 60, right? 60. So to place them in ascending order. If you know what ascending order is, this is what ascending order is. It goes from the lowest to the highest. So this is what ascending order is. So the lowest is 40 over 60, or 2 over 3. 2 over 3, then comma. Second lowest is 45 over 60, or 2 over 4. And the highest is 48/60 or 4/5. That's how we put it in ascending order. Then that. Tick. I can add two fractions by converting to a denominator, common denominator if required. So we need to make them a common denominator. The LCM of 6 and 4 is 12, right? So if you want to make them the same, it's 9/12 plus 10/12. 10 plus 9/12. We don't add the denominators, not supposed to. That equals to 19/12. And that's it. So put tick. 19/12. Yeah? 10 plus 9, 19. And that's what we do. That's what we do. We still have loads more things to learn. In this one chapter, they go through a lot of things. That's what's kind of not fun. They have to do it. I'll just end this video and we're gonna go up to chapter 15. Finish chapter 15. So I can add two mixed numerals. To add two mixed numerals, you want to first convert them into improper fractions and then add them. So you have 3 times 3 is 9, it's 11/3 plus 14/3. That equals to 25/3, and that's the answer. 25/3. Convert that back to mixed numerals. A1/3. That's the answer. A1/3. And we found it. Subtracting them, converting to a common denominator. So we put 5. Sorry. Can I do that? Wait, I can. What's with that? Okay. 5/6, when we convert it, equal to 10/12 minus 3/12. 10 minus 10 minus 3/12. That equals to 7/12. 7/12. That's what it equals to. So 7/12. Can't simplify further. Put a big tick. So 2 more on the video and do part 2. Find the value of 5/2/3 minus 3/1/4. Convert them. 5 times 3 is 15, 17/3 minus 4. They're not the same, so we have to make them the same denominator, so 2 times by 4. So 29, that equals to 29/12. Convert that back to mixed numerals. How many times 12 goes to 29? 2. 5/12. 2, 5/12. Equals to, so we go put a tick. Yeah? You put a tick there. And then after that, you have to go and do this question. I can multiply fractions, proper and / or improper fractions. So then what we do here is 8. How do we multiply fractions? We do 8 times 3 times 9 times 4. How do we do that? What's 8 times 3? 24. 9 times 4 is 36. That's what you multiply. So that's equal to 24 over 36. They never ask to simplify it, but you normally they recommend you to simplify it. But you should simplify it, even if they don't ask. Okay? Let's come factor 6. 12, sorry. That's 2 over 3. 2 over 3, and we take the checklist. So that's all for this video, and I hope you like it. And we'll go to the next video. Yep, thank you.